Hi, this is Mrs. Chris here, and we're going to start doing some stoichiometry. So stoichiometry is basically just the math of chemical reactions, and it's going to deal with if I start with a certain amount of one chemical, how much of another chemical am I going to make, am I going to need, stuff like that. We actually have already done composition stoich. We called it moles. So when we did that whole moles chapter, we actually were already doing composition stoich. And now we're going to move on into reaction stoichiometry. So what we're going to do is we're going to take the chemical reactions from last chapter and we're going to mix them in with some moles in stoichiometry. A couple of things you want to know, it's definitely based on the law of conservation of mass and matter. So you definitely want to know that. It said we'll always keep mentioning that. And again, you have to start with a balanced chemical equation. So going along with your EQ for today, if you don't have a balanced chemical equation, you're not going to have the right mole ratios, you're not going to have the right products or reactants, and then you won't be able to do the problem. So this has to be the first thing you do before you do anything else. Again, it's going to give us, the balanced chemical equation is going to kind of tell us relatively how much of something we need, how much of it we're going to use. So that's really important to us. So the word stoichiometry is Greek, and it comes from the thing that says basically you're measuring elements. The biggest thing is kind of just following the problems. So whenever you're doing a stoich problem, there's going to be two parts. There's going to be the information that they give you, and they're going to give you the unknown. One thing you have to be okay with is that the unknown and the given could both be reactants. They could both be products. One could be a reactant and one could be a product. So it could be kind of mixed up. Typically they give you a mass, but that's not always the case. So, I mean, if they give you masses, typically it's in grams, but just watch out for that because, you know, if it's in kilograms or milligrams, you're going to have to convert if necessary. I'm running out of room, sorry. And again, just make sure what we're going to do is we're going to use ratios from this balanced equation. So it's really important that we know the balanced chemical equation so we can do the problems correctly. So whenever you do problems, you typically have a plan. What we're going to look at today are just real simple ones. But what you'll notice in every single type of problem, we need a balanced chemical reaction. And what we're going to do is we're going to go to moles. So that means a lot of molar masses, a lot of looking stuff up. But if you kind of know what you need and know where you're going, it's really going to help you in the problem. So again, just a couple more examples of the problem types. What we're going to focus on today is called the mole ratio. It's a little cut off, I apologize. But basically, a mole ratio is a conversion factor that relates the amounts of moles between two things in a chemical reaction. So it's basically saying if I have so much of one thing, how much of another thing do I need? And again, it's going to be from that balanced chemical reaction. So you have to make sure you have that. And again, you can't do it without it. So what we're going to be using is we're going to be looking at the coefficients, which, if you remember from last chapter, are the numbers out front. So here's an example here. It's a little cut off, but you have it on your notes. This should say 2Al2O3. When you're making a mole ratio, what you're doing is you're going from one kind of element to one kind of compound or element to another. So for example, if we wanted a mole ratio from Al2O3 to aluminum, all you do is you look up the coefficients, and in front of Al2O3 is 2, and in front of aluminum is 4. So what that means is that for every 2 aluminum oxides, it means I'm going to get 4 aluminums. So you can write that two ways. You can either say 2 moles of aluminum oxide is equivalent to 4 moles of aluminum, or depending on what type of problem you're doing, you can flip it upside down and say that there's 4 moles of aluminum for 2 moles of aluminum oxide. Now you can do this for any combination. You could do it for aluminum to oxygen, you could do it for oxygen to aluminum oxide. So what the big point here is for mole ratios is you need to get the one that the problem is requiring of you. So you want to make sure you get the right mole ratio. So you need to make sure that you're looking at the chemicals they want you to look at. So what we're going to do is just practice a couple, and then just make sure that today you're going to practice them. The worksheet has the answers on it, so my goal is not for you to just get the answer. My goal is to make sure you know what you're doing and how to get there. I'm going to warn you, tomorrow I'm going to expect that you do mole ratios. And the first thing we're going to do is we're going to do mole ratio problems. So you need to make sure that you're okay with it. So what we're going to do here is just use the equation we just had, that aluminum oxide, and we're going to do a kind of little problem. What it says is that we have 13 moles of aluminum oxide, and we want to go to moles of aluminum. So our given is 13.0 moles of aluminum oxide, and then our unknown is how many moles of aluminum. So all we're going to be doing today is just doing one-step problems where you go from moles of one thing to moles of another. So this is just going to be a one-step, and what we need is we need our mole ratio. So when you start the problem, the first thing you want to do is write what they give you. So let me use a color that actually shows up a little better. So we have 13 moles of aluminum oxide. Now, to get to moles of aluminum, we need that mole ratio we just had. Since we want aluminum, that means that moles of aluminum have to go on top, and moles of aluminum oxide must go on the bottom. And again, we do that so that these moles are going to cancel. For the mole ratio, we're going to look at our reaction. So again, you look at what's in front of your aluminum, and that's a 4. So we put that in. And we say what's in front of our aluminum oxide, and that's 2. So we're going to, by doing this problem, we're going to go from moles to moles of aluminum. Make sure you do the math. So we have 13.0 times 4 divided by 2. And what we should get is 26.0 moles of aluminum. So same thing kind of goes as we had with moles. We need to make sure you have the number, which is 26.0. You need to make sure you have the sig figs. And again, our beginning thing had 3 sig figs. So our answer is going to have 3 sig figs. And then you want to make sure you have units, which in this case is moles. And you want to say, what are you talking about, which is aluminum. So our answer formally is, all rounded and everything, 26.0 moles of aluminum. So what we're going to do is I'm just going to break the video up, give you a second in case you need to go back or anything, and then we're going to do 2 more problems, and then we're going to move on, and you're going to practice it on your own.